Hello everyone, and welcome to the AI Research Roundup. I'm your host, Alex. Today, we're diving into a fascinating article by Google Research titled, Unlocking the Power of Time Series Data with Multimodal Models, published November 25th, 2024. This post explores how multimodal models, like Gemini Pro, interpret time series data. The core idea is that presenting this data visually, as plots, significantly improves the model's understanding, especially in tasks like fall detection, compared to just feeding it raw numerical values. This figure illustrates how the model interprets IMU data for fall detection. So starting with the ground truth of a near fall, the data is processed two ways. One, as raw numerical data, and two, as a plotted graph. Then the model, prompted to classify the event, incorrectly identifies it as a fall using the numerical data, but correctly as a near fall using the plot. So this visually demonstrates the advantage of using plots for improved accuracy. This figure presents examples of IMU data correctly classified by Gemini Pro. The top left shows a fall, the top right a near fall, and the bottom left depicts daily activity without a fall. Each plot represents acceleration and gyroscope data across 3 axes, plotted over time. These visuals highlight how the model successfully distinguishes subtle differences in movement patterns when presented with graphical data. Okay, so this box plot illustrates the performance of the plot versus text methods across different models for fall detection. The F1 score, shown on the vertical axis, measures accuracy. And, as we can see, the blue boxes, representing the plot method, generally achieve higher F1 scores than the orange text-based method across all models and shot counts. This reinforces the idea that visual data improves model performance, especially with more few-shot examples. This box plot compares plot and text methods for activity recognition. Again, the blue boxes represent plot performance, and orange, text. Similar to fall detection, plots generally outperform text across models and shot counts. However, the performance gains seem less pronounced here compared to the fall detection task. This figure shows examples of plots used for what the researchers call functional form identification. Okay, so clockwise from the top left, we see a cubic function, then an exponential one, followed by a quadratic, and finally, a linear function. These visuals were used to test whether the model could identify the underlying mathematical relationship when presented with the data graphically. The article mentions that this plot method performed significantly better than giving the model raw numerical data. So, building on that idea of functional form identification, this figure shows examples of 2D cluster counting. Clockwise from top left, we have plots with 7, 1, 4, and 3 clusters respectively. This more challenging task also showed the plot method outperforming raw text data with, 55 to 85% lower error rates when using the plots. This again confirms the advantage of visual representation for complex tasks. Finally, this figure presents a few different visual styles for plotting the same functional form identification data. So we see variations in color schemes, background grids, and marker shapes. Interestingly, the researchers found that these stylistic choices didn't significantly impact the model's performance, indicating the robustness of the plot method itself. So to wrap up this fascinating article by Google Research, they've demonstrated that presenting time series data as plots, rather than raw numbers, significantly improves the performance of multimodal models, like Gemini Pro. This applies to a variety of tasks, from fall detection to complex mathematical function identification. Okay. So the key takeaway here is that visuals unlock a deeper understanding of time series data for these models, offering a more efficient and accurate way to analyze this information. Alright, thanks for tuning in to the AI Research Roundup.